It's space weather. We're looking at no sunspots. A little bit of activity. Small coronal hole still not magnetically connected. No significant solar wind. Here's the sun at 171 angstroms. There is some ejecta in the southeast. You can see it go flying off right in this area. Right there. Look at the 304 angstroms view. I don't think it escaped, but there's a big plasma filament towering down there. To this current moment, it looks like. Some filamentary activity in the northwest. And there are your magnetic lines. Coronal hole down in this area. No apparent magnetic connection yet. Let's look at the latest earthquakes. Head to the United States downgrade service. Look at the last, say, 10 hours. Let's see here. India got a 4.6. Alaska's still getting a bunch of small quakes. Philippines got a 4.6. New Caledonia gets a 4.9 and a 5. Chile a 4.6. Indonesia 4.8. Tonga 4.5. Tajikistan 4.6. 4.9 in Greece. So no major quakes. And this one down here was the largest one in the past 24 hours, I think. Located at the Pacific Antarctic Ridge. Very far south. Zoom that map out a little bit. Get an idea where that is. And there you have it. Head to spaceweathernews.com and look at the data. X-ray flux is flatlined. And looking at the real-time solar wind, solar activity quite weak. The speed has dropped down to about 400 kilometers per second. The density is all the way down to 3.41 protons per cubic centimeter. We don't really see a phi angle signal here. We're looking for a connection to that coronal hole. We don't really see one. BTBZ is still bouncing around. And let's go back to space weather, because the main story is going to be the electron flux. Magnetometer is looking pretty flat, actually. Like a small range there. Lower lows and higher lows and lower highs, that is. KP index is down to 1. And there would be no surprise if that dropped down to 0. You should consider that a low-level cosmic ray alert. There's your electron flux, actually quite high. Keeping an eye on that. Charging hazards, not really too much. And the F2 layer, once again, we're getting this bubble here. It's not looking as discharged as it was. But this discharged area up here is looking a little bit heavily discharged. So a little bit of anomalous stuff there going on in the F2 ionosphere layer. head to theplanetstoday.com. Give you an idea where the planets are located. Once again, if you get out before it's fully light out today, look up in the eastern sky. There'll be an incredible Venus visible. It rises a few hours before the sun does. And let's look at the Space Weather Enthusiast dashboard. Take a quick look at the LASCO C3 and the total U.S. electron count. Let the timestamp show there. See if we can see any of that coronal mass ejection. A little CME in this area, very minor, does not appear to be Earth-facing. Looks like a small comet, actually, at the beginning of the animation there. Yeah, a little bit of coronal mass ejection coming out of the east side of the sun. Again, does not appear to be Earth-facing. Let's move on to the total electron count for the U.S. Not particularly high, but let's look anyway. Let's see a little bit of fluctuation there. Nothing too major. Electron count. Electron flux has stayed under 10 to the 5th as far as the density. And let's look at some articles. Space.com, as our commenters have been very interested about magnets lately. This article 2 days ago, 3 surprising facts about magnets. It's an artist's interpretation of a magnetar. Okay. Magnetar is a type of, we'll say, a massive radio source with a pulsating magnetic field. Anyway, interesting article talking about the way electromagnetism and electrical charge and magnets are all interrelated, and how the electrons are in charge. We'll leave links to all of these articles. Next one, from phys.org. We got another blazar here with a periodic radio signal. Another massive radio source. They're going to call it a supermassive black hole. We just prefer to call it a massive radio source. Our favorite blazar is actually totally different than this one. Cygnus X3. This one is called J1043 plus 2408, which is a really catchy name. Thanks, astronomers. Anyway, blazars are a type of radio-loud active galactic nuclei. And their best guess on this one is that it's 2 co-rotating black holes. That's their words, not mine. Black holes are just examples of radio sources. And for those of you who haven't watched it yet, we'll leave a link to this video. Robitaille talking about what are black holes, science or science fiction. We'll leave a link directly to the video, but the Sky Scholar page is one of our favorite YouTube pages, and if you just go to our own page, youtube.com/mashomash, our first officially endorsed channel is Sky Scholar. And here's a little snippet from the video.
Today, we are discussing black holes. To start, they aren't science. A scientific theory is falsifiable. That is to say, when you test a hypothesis, you must be able to get back the answer that the hypothesis is wrong.
Anyway, listen to Robitaille's video about black holes. He will explain why they aren't science. Next, let's go to another electrical universe type article here from phys.org. Rosetta witnesses birth of baby bow shock around comet. Basically just an article showing that bow shock has been measured. And how could that be? Well, Obviously, comets have a magnetic field. And here's a little animation of Rosetta flying through said magnetic fields. Interesting article. We will leave links to that also. Now, let's talk about another ridiculous article. Astronomers find that dark matter dominates across cosmic time. Dark matter, more non-science, completely based on math as opposed to observations. Dark matter is one of the things that got me out of science in general, because when I was in college astronomy class, I thought WIMPs were ridiculous back then. Those of you who are not aware of what WIMPs are weakly interacting massive particles, aka dark matter. At least this stuff is all being debunked now. In any case, this article... Anyway, just read the article if you want to see them clamoring about how much mass dark matter has, how much missing mass of the universe, why galaxies move the way they do. It's ridiculous. Here's another one about dark matter. Could negative mass unify dark matter? Here's an artist's rendition of dark matter. Isn't it spooky looking? Ooh, look at that. I'm going to have nightmares. We were going to look up an artist's rendition of a unicorn to, you know, stick with the theme of things that don't exist. Sadly, dark matter is just a way to make the bad math work. Oh boy. Astronomers' measurements of the cosmos suggest that visible material such as stars and gas account for only 5% of the universe. For example, the way galaxies rotate shows gravitational effects from about 5 times as much matter as we can see. An invisible entity dubbed dark matter. Ooh. It's not magnetic fields or anything like that. Nope. They can't get over the fact that gravity doesn't run the universe. We will leave links to that article also. Now, while we're talking about places where there isn't anything, like the search for dark matter, how about the mysterious supervoid, the largest, quote, object, end quote, in the universe? It's billions of light years in diameter. 1.8 billion light years, that is. And it's a space in the universe where there should be about 10,000 galaxies. And there's like 6 galaxies, if I remember correctly. Another interesting article. Can't figure out why that part of the universe is so cold. Maybe it's full of dark matter. Ooh. Also, the article totally refutes itself and the hypothesis about dark matter, because it suggests that this void is actually pulling the Milky Way galaxy toward it, the opposite of what dark matter is supposed to be doing, repelling things. Let's give you a value-added service here for all of our subscribers and our viewers. Let's look at the U.S. weather radar for once. Every once in a while you got to do it, right? So, you got heavy snow and rain in Washington. Some nasty-looking wintry mix and some snow in South Dakota there. Snow is starting to set into the northeast, and the south characterized by rain. We got a convergence zone down in this area. Let's look at it on the water vapor map. For all of you who are interested in when the snow's going to start, when the snow's going to stop, etc., let's speed that up. There we go, that's better. You can see some drier mass of air pushing down to the basically due east. You got this anticyclonic zone down here, West Texas and northern Mexico. And really, we've got 2 atmospheric rivers. There's one that's coming up here, and there's one that's forming like this. And this is going to start to wreak havoc. And let's just do one more zoom in on that area, that anticyclone, so we can look at some electrical fields. I'll say electromagnetic fields, or evidence thereof. And there you have great examples of electromagnetism in the atmosphere. You can see this system is wanting to rotate clockwise, characterized by a major positive charge. You can see the way the water vapor is moving and all these field force lines lining up parallel with each other, perpendicular to the mode of travel. An interesting little tidbit, although not tropical tidbit. And there you have it. Back to the sun on 171 angstroms. Thanks for watching, everybody. Please don't forget to like and subscribe if you enjoy the videos. Please recommend to your friends, share on social media. Help us get to 1,000 subscribers. We are taking suggestions on what we should do for the 1,000th subscriber special, or 1,000 subscribers special. Any suggestions, place them in the comments. We'll be doing it all again tomorrow. Remember, when you're staring at the sun, don't drink. And if you drink, stare at the sun anyway.